evaluate. Remember, underneath a whole number, we have invisible ones. So 3 times 40 is 120, and 8 times 1 is 8. All of these are going to come out to whole numbers. So 120 divided by 8 is 15. Complete all 5 problems for your warm-up. At a school carnival, students play a spinner game. The spinner has 4 equal sections, numbered 1 through 4 as shown. To play the game, a student spins twice and adds the 2 numbers the arrow lands on. If the sum is greater than or equal to 5, the student wins a prize. Well, if we add them, 1 plus 4 would make 5. 2 plus 3 makes 5. 2 plus 4 is 6. 3 plus 4 is 7. So there are several options that would give us something greater than or equal to 5. But you could also land on a 1 and a 2, or a 2 and a 2, or a 1 and a 1, or a 1 and a 3. So in part A, it's a prediction of how likely you think this winning a prize is. I think it's likely, but not certain. I think it's a little bit more than equally likely. I think there are more possibilities for getting 5 or more than for less than 5. But we're going to do what's called an experiment, and we're going to do some experimental probability to figure out what our chances of winning might be based on an experiment. It says, play the carnival game with your partner 15 times. Complete the table by recording the result of each spin and the sum of both spins. Alright, so I'm going to go through and finish the rest of these. Feel free to follow along in your table with what my results are, or feel free to continue to spin on your own. The website Didax has some digital manipulatives that you can use. You're just going to change the number of sections to say 4, so that way you have the 4 things, and then you can click spin and record your results in your table. Here are my results for all 15 turns. Part C asks, what is the relative frequency of winning spins? So we won if we got a 5 or more. And that happened 1, 2, 3, 4, 5, 6 out of the 15 times. What sum occurred most often and how many times? Let's see, we had 4 show up 1, 2, 3, 4, 5 times. We had 3 show up 3 times, so that's not the highest. We had 5 show up twice. We had, 3 times. 1, 2, 3. It looks like 4 is going to be the most. What sum occurred least often and how many times? Well, let's see. 7 only showed up once. 6 showed up once. 8 showed up once. And 2 showed up once. Consider the data you collected about spinning the game. Mark the probability scale to show the probability of winning a prize in the game. Well, we saw that it happened 7 out of the 15 times. No, 6 out of the 15 times that they would have 5 or more. So 6 out of 15 is less than 1/2, which if we were to convert this to a decimal is 0.4. So if this is 0.5 here at 1/2, we would mark it at 6 out of the 15. So 1, 2, 3, 4, 5, 6. Out of the 15 total. It is closer to unlikely than likely, but that's just based on my experiment. Now, in reality, our theoretical probability may be something different based on what we would expect from the numbers in the spinner. This is just based on my experiment. So if you were to complete your experiment, you may end up with a different experimental probability because you spun and landed in different spots. It says you and your partner have 20 cubes, which were randomly pulled from a large bucket of cubes. These 20 cubes represent the outcome of 20 trials where a cube was randomly pulled from the large bucket and then replaced. In the following table, record how many cubes of each color you have. I'm not able to change the color to black or white here, so we have blue and orange instead. We're going to call this one black for the sake of the following questions, and then the orange we'll call white. Then we also need to record the other colors. We have 1 yellow, 2 green, 2 red, and 3 purple. Then we need to answer the following questions regarding this set of data. Based on your set of 20 cubes, determine the empirical probability for each event. That means the experimental probability. So randomly pulling a black cube from the large bucket of cubes? Well, there were 9 out of the 20 cubes. C says randomly pulling black or white. There were 9 black and 3 white, so if we combine those to make black or white, that is 12 out of the 20. Then randomly pulling a cube that is neither black nor white from the large bucket of cubes. If 12 of them are black or white, that leaves 8 that are not black or white out of the 20. And then E says randomly pulling a yellow cube from the large bucket of cubes. There was 1 yellow out of the 20. All of these were pulled from a larger bucket. In that larger bucket, do you think that there's the same amount of black, white, yellow, green, red, and purple? Well, because we have 9 black and very few yellow, I would assume that the larger bucket has more black in it than yellow cubes. If we had 240 cubes in the bucket, how many would we expect to be black? We had 9 out of 20 that were black. So if we changed our total to be 240, how many would we expect to be black? Well, we can cross multiply and divide just like we did with percents in the last module. And if we did that, we would expect 108 to be black out of the 240. 9 times 240 divided by 20 gives us 108 out of 240 to be black. That is the end of lesson 2, talking about experimental probabilities.